So let's do an example where we have to decide what quadrant we're in based on information given to us. Alright, so the problem is, which quadrant are you in when sine of theta is less than 0 and when tangent of theta is greater than 0? As in, when sine of theta is negative and when tangent of theta is positive. So remember, hopefully, you're catching on to these patterns, that sine of theta is the y value over the r value. And we know that the r value, the radius or the hypotenuse, is never going to be negative. So really we're just focused on the y value here. So we're looking for quadrants where the y value is negative. Alright, so which two quadrants have a negative y value? That would be quadrant 3 and quadrant 4. Okay, now let's focus on tangent. Where would tangent, which is y over x, be positive? Okay, so basically we're looking for the quadrant that has a positive y value and a positive x value, or a negative y value and a negative x value. If they are opposite of each other, then we know that tangent would be negative, which isn't what we're looking for. So the positive over a positive, the y value, positive y and positive x, is going to be in quadrant 1, where everything is positive. And the negative over a negative is going to be in quadrant 3, where everything is negative. Okay, so we want to choose the quadrant that has both of these represented. Let's do an example where we have reciprocal trig functions. So we're first looking where secant is less than 0. Alright, so let's think about what secant is. We know that it's the reciprocal of cosine, which is x over r, so we know that secant is r over x. And just like what we did up above in the example with the sine, we're really not concerned about the r because the r is never negative. It's always going to be positive. So we're just focused on where the x value would be negative. Okay, so that is over here in quadrant 2 and over here in quadrant 3. Alright, so now let's look at cotangent. So we're looking for where cotangent would be negative. Cotangent, being the reciprocal of tangent, is x over y. But it's going to have the same patterns as tangent. It's going to be negative when we have opposing signs. So either when x is positive and y is negative, or when x is positive and y is negative. So that's going to be where x is negative and y is positive is going to be in quadrant 2. And where x is positive and y is negative, that's going to be in quadrant 4. Okay, and then we want to choose the quadrant where we have our 2 check marks, where these two necessities are met. Okay, so we would choose, for the first example, we would choose quadrant 3, and for the second example, we would choose quadrant 2. So we do kind of the same routine that we do for these classic trig functions as we do for their reciprocal function. So here's another kind of example that we can use that idea that we just learned with which functions are positive where, and applying this idea that we did last class with when we were given ordered pairs and when we have to draw a triangle. Okay, so let's kind of start breaking this down. Let's first look at the signs, as in positive and negative, that we have here. So we have sine of theta is positive 1/3. Okay, so I know that I'm going to have to be either up here in quadrant 2 or up here in quadrant 1 because the y value has to be positive in this case. Okay, let's look at the other part that's given to me. Cosine of theta is negative. Remember, cosine is x over r, so we're focused on the quadrants where x is negative. So I could be over here or I could be over here. Alright, and I want to pick the quadrant where they overlap. So I'm obviously, see how I'm using that tool that we just learned how to use? I'm deciding that I'm over here in this quadrant. Here's my theta, here's my right angle, and I draw my right triangle in that quadrant. Alright, so now we're going to actually use the information that they told us. So we know that sine of theta is y over r. So that goes hand in hand with this ratio that's given to us. That 1 on top is your y value, and that 3 on the bottom is your r value. Same thing for cosine. This number on top is your x value. This number on the bottom is your r value. Okay, so hopefully you're noticing that this makes sense because our x value, our y value, and our r value, they're coming from the same triangle. So we see that on both of these ratios, we have 3 in the denominator. Well, that's a good sign because the radius is supposed to be 3. Okay, that means my x value is -2 root 2, and my y value is 1. Okay, and this problem says to use the given trig functions, we have these 2 given trig functions, to find the exact value of the other 4 trig functions. Okay, so let's just dive right in and start doing this. So we know that tangent of theta is the y value over the x value. So we're going to do the y value, which is written here, 1, and the x value, written here, is negative 2 root 2. Okay, and that isn't quite exactly how I like to see that. We know that we need to rationalize this, so we're going to be multiplying by the square root of 2 on top and bottom. Okay, so if we multiply by the square root of 2, we're going to get the square root of 2 on top, because 1 times the square root of 2 is the square root of 2, over negative 2, and the square root of 2 times square root of 2 is 2. So negative 2 times 2, which is 4. Okay, and we like to put a negative in the front, not in the denominator like I mentioned today. Okay, so there's tangent of theta. We've gotten one of our 6 trig functions. Okay, so what about, let's do the reciprocal of sine. So cosecant of theta is going to be the 1 over 3 flipped over. So that's just going to be 3. That was quick and easy. We didn't have to do any rationalizing. All right, secant of theta is going to be 1 over cosine of theta, which is just going to be flipping it over. So it's going to be 3 over negative 2 root 2, and then we're going to have to rationalize this. So we're going to multiply by the square root of 2 over the square root of 2, which is the equivalent of 1. That's what we do when we rationalize, is 3 root 2 over, again, just like the last example I did with rationalizing, we had negative 2 times the square root of 2 times the square root of 2, which becomes negative 2 times 2, which is negative 4. Put the negative at the front. So we got kind of the same pattern there. And then the last example, cotangent of theta, that's going to be the reciprocal of tangent of theta. So this was our final answer for tangent of theta, which you can then flip over and you can rationalize, or you can just go back and look at your unrationalized answer. I think that's the easiest thing to deal with, because then you don't have to do any extra work. So we just go back to our not pretty answer and we flip it over. Now it looks really good. Okay, so at this point, I want you to try to do this problem on your own. I want you to pause the video, see if you can figure out which quadrant you're in, draw your triangle, and then figure out what all the sides of your triangle are. Alright, so at this point you should have attempted the video on your own. Now we'll talk about the line of logic here. So first thing that I would think to myself is sine of theta, that's my y value, so I want to think about the quadrants where my y value is negative. Okay, secant is 1 over cosine of theta. So we're focused on the x values and we want the quadrants where the x values are positive. So that means that I must be down in quadrant 4. Okay, so here's my right angle, here's my theta, and now I'm going to decide what all my sides are. So I know that sine of theta is y over r. So I know my y value is negative 2, I know my r is 5. And I know that secant, being the reciprocal of cosine, is r over x. Well, this makes sense because I already found that the r was 5, and the x value here is root 21. Now I can evaluate the rest of my trig functions. So let's see, I need cosine. Cosine of theta is x over r, so the square root of 21 over 5. You can also see it's the reciprocal of this up here. And you may be wondering why I did not give this initial thing to you rationalized. The reason is I think it would have been a little bit too confusing to try to go backwards and figure out what it would have been initially. So I was being nice there. Tangent of theta is y over r, so we know that the y value is, y over x. So we know the y value is negative 2. We know the x value is root 21. We rationalize this and get negative 2 root 21 over 21. So there's our tangent. Okay, let's go ahead and do cotangent since we just did tangent. We can just flip over the unrationalized, not pretty version of tangent. So negative root 21 over 2. And then lastly, we need cosecant. That's going to be the reciprocal of sine. Sine was negative 2/5, so this will be negative 5/2. So there's how that works. Hopefully you did that successfully on your own. Okay, for example 4 in the notes, you need to find the exact value of the remaining trig functions when you are given just one trig function this time. So we are told that sine of theta is 2 over 3. We know that sine is y over r, okay? But how can we decide what quadrant we're in? We know sine is positive here and here. That's great. We've got it narrowed down to 2 quadrants. So we need to use this other piece of information to decide specifically which quadrant I'm in. So where is cotangent going to be negative? Well, think about cotangent is x over y. It's going to be negative when they have opposing signs. So that is not quadrant 1. That's going to have to be quadrant 2 where x is negative and y is positive. So there's my triangle. I know my y value is 2 and I know my r value is 3. Now I have to do a little bit of extra work to find the x value. So I'm going to use Pythagorean theorem. I'm going to do 2 squared plus whatever the base of this thing is equals 3 squared. So 4, that's 2 squared, plus b squared equals 9. So I know that b has to be the square root of 5. Hopefully you guys got pretty good at Pythagorean theorem from when we had conic sections. Okay, so now that we've drawn our triangle, we know, I like to draw my triangle before I try to decide what my x value, what my y value, and what my r value is. Okay, the reason I like to draw my triangle is because when I just did Pythagorean theorem, this did not give me a sign. I mean, yes, we got that it was positive, but Pythagorean theorem is never going to give you a negative. But look at our picture. We know that we're in quadrant 2. Had I not drawn this picture, I may have missed this negative here. So that's why I think it is so crucial to draw a picture, because Pythagorean theorem does not give us the negative. We have to add that ourselves. So we know that x is negative square root of 5, and I may have missed that negative had I not drawn a picture. The y value is positive 2, the r value is positive 3, and you're going to evaluate the rest of the trig functions using whatever the ratio is. For example, I'll just do one. Cosine of theta is x over r, so we know that that's going to be negative square root of 5 over 3. You can go through and do the rest of the trig functions. Good luck.